Okay, we already went over some basic concepts about hypothesis testing, and we learned how to test a claim about a population proportion. And in this session, we're going to learn how to test or testing a claim about a mean. Okay, this mean is the population mean, mu. And do you remember what's the symbol for sample mean? X bar. Okay. Now again, there are two requirements. The first one, the sample has to be simple, random sample. Okay. And the second one, okay, so either the population is normal or n is greater than 30. So that's the case that we can test about a population mean. However, in most of the time we don't know sigma, right? Okay. So anyway, that's what I'm going to do this chapter or this session when we test about the population mean. We probably going to see this in the question that this a simple random sample, and then sometimes they tell you the population is normally distributed. You can see this is, I just make it distributed. The population is normally distributed, or you have a large sample size. All right. Now, in most of the time, when we learned the confidence interval, most of the time the population standard deviation is unknown, and then we use t. In this case, we are going to use t. Okay. So the t-test statistic is this. That should be the x bar, which is your sample mean minus the mu of x bar over the square root, the standard deviation of x bar. But we don't know that, so we're going to use s over square root of n. Okay, or you can just use x bar minus mu over s over square root of n. So you can use either this one. That's the same thing. And we learned that the mean of the sample mean should be the same as the population mean, right? That was in very early chapters. I forgot which one. But anyway, so that's a t statistic. And also there's a degree of freedom, and that is also n minus 1. It's all the time, right? N minus 1. So we can use the t table, and please have your t table with you because we're going to use that a lot in this session. All right. Now, let's look at the example here. Okay. I'm going to use this example to show how to do how to do hypothesis testing for a population mean. Now, the author obtained times of sleep for randomly selected adults subjects included in the National Health and Nutrition Examination Study. And these times in hours are listed below. So they give you the data. They give you 4, 8, somebody sleep 4 hours, 8 hours, 4, 4, 8, 6, 9, 7, 7, 10, 7, 8. Okay. 2, 3, 4. Okay. So once you have this data, let me give you let me give you some information. N is 12. Remember what is n? N is the sample size. Okay. To save your time, I give you x bar, which is the mean. So you add all those numbers together, divided by 12. So I have 6.83. So for the 12 people included in my research, their average sleeping time is 6.83 hours, and the sample standard deviation is 1.99 hours. Okay. A common recommendation is that adults should sleep between 7 hours and 9 hours each night. Use the p-value method. I don't care. It doesn't really matter. With a 0.05 significance level. Okay, that's a very important information. I want you to test the claim that the mean amount of sleep for adults is less than 7. Because when people come here, they look, ooh, there's a lot of 4s. So they said, oh, somebody said, look, the people's average sleeping hour is actually less than 7 hours. H-O-H-A, when they say the average sleeping hour less than 7, which is this, mu less than 7. Got that? And then here will be mu equals 7. See, we have the claim, we identify the claim, this is our original claim, right? Okay, and then we put them in null hypothesis and alternative hypothesis. And alpha is given. So the next step is we need to we need to calculate the test statistic, which is this. T equals x bar minus mu over s over square root of n. All right, now let's see. I do have all the information, okay? I have x bar, which is 6.83 minus mean is a 7, divided by standard deviation s, sample standard deviation, and then divided by the square root of 12. Okay, so this is how you enter the value, and here is x bar, here's the mean. Mean is the one that you have in the null hypothesis, okay? And then s over square root of n, and my answer is negative 0.29. That's my t. Okay, so let's see. I'm going to draw the curve t. Do you remember the t is also bell-shaped and symmetric, and the center is at 0, and here's a t, and degree of freedom is n minus 1, in our case is 11. All right, now here is, it's a less than, so it's a left tail test. How much is this little tail? 0.05. And we're looking for this t, right? It's going to be a negative number. Can you see that? All right, now the t table I have, because for the row I use 11, which is the degree of freedom, 11. And for column, it's a one-tailed test, 0.05. Did you see that? They give you that already. So one tail, 0.05. And you go down here, the degree of freedom 11. So you get a 1.796. And it's a negative, 1.796. Okay, why negative? Because it's to the left of 0. All right, now where is your test statistic? Is it only negative 0.29, so which is here, right? Is this in the rejection region? No, the shaded, under the shaded area, that's a rejection region. Here is not, so you'll fail to reject HO. Okay, you'll fail to reject HO. Not done yet. You have to use this flow chart to write your final result as the your answer. So does the original claim contain the condition of equality? No, our original claim says it's less than 7. So again, we go to the left. Do you reject HO? No, we fail to reject HO. So we're going to say there is not sufficient evidence to support the claim that the average sleeping time less than 7 hours. Okay, so I'm a little lazy. I didn't write it, but you have to write it. Okay, so that is this sample. All right, and I want to say something else. If you have in this case, you might have noticed that I only use the critical value, compare the critical value with my test statistic. Can I use the p-value? Here's a 0, here's a t, here's a df is 11. Let's see, what do we have for t11? And then I have see, my test statistic is negative 0.29, and they don't have it. they only have here, the 0.29 is between 0 and 697. What is the 697? Here is 0.697, and that tail area 697, that tail area is one tail, that's 25%, so it's 0.25. All right, so my test statistic is negative 0.29 here, and that, which means my p-value starting from here to the left is even greater than 0.25. I don't know exactly how much it is, but I think it is definitely, it's a greater p-value. So I fail to reject HO. Now, think about what we have learned in early chapter about the confidence interval. If you construct a 95% confidence interval, okay, if you construct a 95% confidence interval, is that from the mean, from the x bar, and they go to the left and the right by the t alpha over 2 s over square root of n, right? Because you plus that and you minus that, so you have this number and this number, right? And then when you have your test statistic, you compare with this. So it could be either outside or inside. So I think in the note I mentioned that you can use either way to test your claim if it's a two-tailed test. If someone said mu equals 7 and mu is not equal to 7, for example, I have this HO and HA. And then alpha is 0.05, and I also have my x bar 6.83, and I have my S is I think it was I forgot what was it. It's 1.99, and my sample size is 12. Now, you might want to practice to construct a 95% confidence interval for mu. Okay, to see whether this confidence interval contains 7 or not. That's one way to do it. And the second one is you test, no matter it's a one-tail, two-tail test, your test statistic t should be the same, okay, 0.29. And then you're going to use this t, here's a 0, and the df equals 11. Okay, now alpha 0.05, but two-tailed, you have to go to here. Okay, so this is 0.05, df 11, we get 2.201. So my critical value here is 2.201 and negative 2.201. And each tail is alpha over 2 or 0.025. This one is also 0.025. Now, those are your rejection region, but your test statistic is negative 0.29, which is here. So you fail to reject HO. Okay. And when you fail to reject HO, then you're going to conclude that, well, it's not, you fail to reject HO, that means you most likely probably, okay, you cannot say that, but you most likely you think this might be true, so it could be 7. And when you use the confidence interval method, you're going to see that this interval contains 7. Okay, so that is this first example, and we're going to do the second example. Example 2, we're going to test the population mean. So example 2. The body temperatures measured for a simple random sample of 106 adults, that's N, is 106. Okay, at 12 a.m. has an X bar for this 106 people. The X bar is 98.2 Fahrenheit, and the S is 0.62 degree Fahrenheit. Okay, and I'm going to ask you to use 0.05 to test the common belief that the population mean is 98.6. So the common belief, that's a claim. The common belief means mean equals 98.6, isn't it? So can we get a HO and HA? So this one is mu equals 98.6, and this one is mu is not 98.6. I don't care whether it's too large or too small, but it's just not equal to. So we know this, we know alpha, and then we're gonna calculate the the test statistic. Okay. T equals x bar minus mu over s over root n. So that would be x bar is 98.2 minus 98.6 divided by s is 0.62 over square root of 106. And I use calculator, I get a negative 6.64. All right, now what is the degree of freedom here? Should be 106 minus 1. 106 minus 1, which should be 105. All right, now I'm going to draw the graph. And keep in mind that's a two-tailed test because here's not equal to. So I have a T, I have a DF, 105. And I want each little tail to be half of alpha, which is 0.025 and 0.025. Okay, do not write a negative because right now we talk about the area under the curve has to be always positive. That's not the problem. The actual problem is this. Did you notice that the degree of freedom go up to 30 and then 40, 60, 80, 100, and 1,000 and infinity? If it's infinity, then that's the same as z. So we don't know what to do, so we just take 100. That's the closest number we can have. And it's a two-tailed test for 0.05. Two-tailed test for 0.05. Did you see this one? So I will use this column, and then I'm going to use this row 100. I got a 1.984. So that will be 1.984, and here will be negative 1.984. Now, do you see this? That's the difference between one-tailed and a two-tailed test, right? You have positive and negative. My test statistic is a negative 6 something, so it's outside the paper even, so it's somewhere here, so it's negative 6.64. It's definitely in the rejection region, so we are going to reject HO. Okay. And that is my common belief, right? So the common belief, that's my original claim, contains equality. Yes, the common belief says it's 98.6. Do you reject HO? Yes. So we reject HO. So we're going to say here, we're going to answer the question says, there is sufficient evidence to warrant rejection of the claim that whatever the common belief, okay, the common belief is the population mean, or the population body temperature mean is 98.6. Again, I'm not writing all the words here. It just so as long as you have this review sheet with you, then you're okay. You can just do it. Okay, so I think till this moment we finished all the hypothesis tests. Oh, there's one more thing. I'm so sorry. There's one more thing. This. You might have noticed that sometimes we use Z to test a hypothesis testing. Okay, and when will we do that? We're going to do either the sample, it's a simple random sample, and then it's either n is greater than 30 and it's normal or normal. And the other one, sigma is no. Okay. In very rare case, sigma is no. When sigma is no, then the test statistic will be z. So that would be x bar minus mu over sigma over root n. So I'm not going to the detail about this because I don't think we're going to see this very often because most of the time I have to say 0.99% of the time that we don't know the population standard deviation. Okay, so that is how to test a claim about the mean. I hope that you're okay and you can understand this and you're ready to do the homework.